So suppose n equals 0 to infinity of an xn has radius of convergence Ra. And you've seen this before. The sum of b and xn has radius of convergence Rb. Then the product of the series is one series times the other series. Now they say it then equals Cn times xn. But Cn is just A0 Bn, A1 Bn minus 1, all the way down to up to An, and then B0. So that comes from A0 B0 will make the constant term. For the term with x to the 1, it'd be A0 times B1 plus A1 times B0, because that's B1 and A1 are the x terms, but then they have to multiply by the constant terms to still have a power of 1 in x. Does that make sense? And then to get a power of 2, if you think about it, it's the constant term of A times the x squared term of B. Then the x term of A times the x term of B. And then the x squared term of A times the constant term of B. Does that make sense? And so forth. So each Cn is given by that expression there. And the radius of convergence is the minimum of Ra and Rb. Okay, so let's have a look at the first question, or one only question. Okay, let the sum of n equals 0 to infinity of a and xn equals x over sine x be the power series expansion of x over sine x, where x does not equal a multiple of pi, because otherwise sine x would be 0. And it'd be undefined. And k is in natural numbers. Use the Maclaurin series expansion of sine x to find AO, A1, and A2, just up to A2, so we only care about degree 2. So that x over sine x is approximately equal to AO plus A1x plus A2x squared for x in here 0. Now, first of all, from a previous lesson, sine x equals x minus x cubed over 3 factorial plus x to the 5 over 5 factorial minus x to the 7 over 7 factorial blah, blah, blah. Now I'm thinking, since I only care about it up to x squared, I'm thinking surely that'll be enough terms to worry about. We don't want that. We want x over sine x. And we're going to let that be. They want AO, A1, A2. In other words, we're just going to use this, what they gave us here. So x on sine x is also, I should say approximately, AO plus A1x plus A2x squared, except I don't know what that is. I could do, since I know the Maclaurin series for sine x, I'd like to get sine x out of that denominator. Usually with an equation, what do you do to get sine x out from the denominator? Exactly, multiply both sides by sine x. So let's actually do that. Cancel, cancel. X approximately equals to sine x outside of AO plus A1x plus A2x squared. Oh, that's looking like a product of two series. That's good. And that equals the sine x. I'm going to sub in the Maclaurin series for sine x in there. So I'm going to get this thing up here. So it's x minus x cubed on 3 factorial plus x to the 5 on 5 factorial minus x to the 7 on 7 factorial. I think that's enough. Plus dot, dot, dot times A0 plus A1x plus A2x squared. So then I've still got x on this side. So x equals, or approximately equals, let's think about this. What will the term will there be a constant term first of all? No, because there's no constant in here. So I can't multiply it by something in a constant term. Will there be an x term? Just x. Yeah. What will that be? Just A0x, because every other term has x's in it, so you'll get a multiple of x, like an x squared, x cubed, blah, blah. What about x squared? How would we get x squared? Yeah, that's the only way. A1x times x, so it would be A1x squared. What about x cubed? There's a couple. Okay, that's good. So let's tell me what those couple are. A2x squared and x, which means it gives me A2x cubed. I might write it out like this for now. What other way could we get x cubed? So it's this one times this one, which is at minus A0 x cubed on 3 factorial. Is there any other way? I don't think so either. And then now, I don't actually care about any terms bigger than that, so I'm just going to go plus ... And then I might just take the x cubed out now. So therefore, x equals a0x plus a1x squared plus a2 minus a0 over, do you want to put 6 now? We can, or we can leave it as 3 factorial, x cubed, plus ... All right. Is everything okay so far? Now, first of all, why aren't I going any bigger? Well, I only really want a0, a1, and a2. Notice, girls, here I've got a0, here I've got a1, and then this expression I have a2, right, in there. And there's also a0 in this one as well. Now, but I've got all the ones I want, so I don't really care about the rest. I don't care about a3, a4, a5. Do you understand that? Because that's from the question. I only care about a1, a2, a1, a0, and a2. So everything okay so far? Now, what can we do? Like, for instance, what's a0? We can literally read it. What's a0? 1, because what are you actually doing? Equating coefficients from this side and this side. Equating coefficients. Do you get what I'm saying? So let's write that down. Oops, sorry. Okay, so I am now equating, because it's a polynomial, and that's something we do with polynomials, equating coefs. I often write coefs like that. Let's go. There's no constant term on either side. Using the x terms, so I might go look at the x terms, compare the x terms, and we see a0 is 1. Now, watch this. Here's an x squared term. Is there 1 over here? No, there isn't 1. There's like nothing, 0. So what is a1? a1 is 0 because it's like 0x squared on this side. Does that make sense? And now, what do I do with the next bit? Exactly, because there's no x cubed term on this side, all of that coefficient equals 0. So a2 minus a0 over 6 equals 0. But wait a minute, a0 is 1 from up here. So a2 minus 1 over 6, equals 0. Therefore, a2 equals 1 on 6. Okay, now what was the question? It just said find a0, a1, a2. We're finished. That's it. Does that make sense? Yeah. But we can also say, therefore, in your question, girls, Girls, back in the question it said x sine x equals a0 plus a1x plus a2x squared. x1 sine x equals a0, which is 1, plus a1 times x, but a1 is 0, plus, what was it, a2x squared? So x squared on 6. Yep. So in other words, that is the Maclaurin polynomial for that expression, except only going up to degree of 2.